Hi, I'm Bob Dunsmore, and I'm what you call a solar energy freak. I started building solar systems like we're going to build today, beginning in 1976, in the coldest place in continental United States, up here north of us in Alamosa, Colorado. The collector that we're building today, we are going to place vertically on the Senna home. So we measured right here where the center of the trailer is, the center of that window, and we brought the center line down here and then perforated a hole for the hot air or the cool air. This will be the cool air return into the collector, and the hot air will be delivered through this hole right here all the way to the north end of the trailer under the floor. This is going to be the inside of the collector, and we thought we'd protect the plywood from weather by putting a C-channel under it like that. So this is going to be a perimeter made out of metal. We used to make them out of wood, and they started to char with the heat. All the air is going to move in here underneath the absorber plate, and then eventually through those holes right there in the foundation part of the house, and then we'll blow it all the way to the north end of the house through this duct stovepipe right here. 4-inch stovepipe, 60 linear feet, take it all the way to the north end, which is the coldest part of the house. And then it'll dump it out. The heat will stratify under the whole floor of the trailer, creating a radiant heat source of the entire floor. To take an extra step of precaution, we're going to put silicone caulk on this so that we don't get any fibers moving into the airspace. I called Andy Zog, who invented this collector years ago, with Rick Willett of the San Luis Valley. That's why we call this the Willett collector. He recommended I use denatured alcohol.
That's fine too.
To get any oils that might be left on this during the machining process. Okay. This ductboard insulation will be inside the collector, and the air is actually going to move right over this surface. And just to be extra cautious, we're going to put silicone caulk with using spatulas or whatever to smear a real thin layer over this fiberglass actually, so that it won't move into the airstream. We've opened up collectors 40 years after using that, and it works just fine. So silicone, the side of the that faces the air chamber. I want to point out that we used to do it this way. We used to use this side, thinking that was a great place for the air to move. And after a few years, we found little flecks of aluminum in the airspace. So we don't do it that way anymore. We do it this way. And the silicone, which will be smeared here in a moment, will take care of the problem of fibers in the airspace. Shows a shaded area here, which is the absorber plate. And to be sure that we cut it at the right dimension, we were calculating that the outside C-channel is 1 inch in, and the absorber plate will become right up to that ductboard insulation in there that's in a vertical position. So if we take the outside dimension of the solar collector and subtract 1 inch here, 1 inch on the other side, 1 inch at the top and 1 inch at the bottom, you get the absorber plate dimensions, which is 77 by 47 minus 2 inches in each dimension, so it'd be 75 by 45. And I'm gonna get Craig's help now to bend the C channel and attach it to this. We're gonna make a little noise now. We need to cut off this inch right there and then cut this right down through here. That is the 77 inches by 47, which will bring the glass half an inch from the edge. The glass will come half an inch in. And so the collector dimension is all designed based on the dimensions of the glass, okay? This very important part of this instructional video will be how to do this right. And that's why I'm so glad Craig's here, because he's worked with metal for many years. Now what we want to do is have the corners of the collector be one piece. We don't want to have it two pieces meet at the corner for obvious reasons, no? So this piece of metal will come underneath, and then will be bent this way by cutting slots and then bending it this way. And then another piece can come and meet within a certain distance, so that we only need a small overlap of maybe 2 inches here and 2 inches over here with a 4-inch piece of C channel. I'll show that.
Yeah. Again, if you look at this now, if I lay that up against the square, it's a 90-degree cut. See?
Okay, now for the first quiz question, why do you think we have a lip right here? The reason, it holds the duct board in there. That insulation will be coming up vertically, and it traps it in there so it doesn't tend to come out like in the last collector, right?
That's fine.
I'll show you what I think what might be the best way is to have this go in first. And I think we might be able to make it fit right now, right?
Yeah, it should fit.
We could go ahead and do it now.
Yeah.
So you have to bend it a little bit to make it go in. It, We're going to flip this over and put in the 2 holes for the hot and the cold air flow. You just create the manifold.
I'm 4 7/8 tall. I'm 4 7/8 tall. And then center line to center line, I'm right at 39. What we're doing is we took the layout from the wall, those holes over on the other wall over there, and they're 39 inches apart on center.
Here are my
so
drivers.
We're 39 inches apart, and to make sure we're consistent on our panel, I measured from this side up and matched it on this side. So this is 4 7/8 high here, 4 7/8 high here, and then from each side we're 4 inches in, 4 inches in. So that way they're consistent in the layout on the panel, plus they're consistent to height, and they're matched to the holes that are already drilled in the house. And you can't see where the pilot hole is. So what I do is I drill a pilot hole with a smaller drill bit where I can actually see the bit being in the center of my lines. Okay? So I drill my pilot hole. And now, when I start in with this drill, see, my pilot hole is already predetermined. So that way I'll be sure to line up where I belong.
That's great. I learned something
Okay.
today.
And on these, when you're working with these, you don't have to bear down on them. And if you bear down on them, it's a good way to have the drill kick around and hurt your wrist. So just go easy and let the cutter do the work.
Vince is getting the final screws in for the perimeter C channel and making that real firm. It's not going to go nowhere, as they say. And then we're going to flip this over so that we can begin finishing the inside where the air chamber will go, and then the dead air space between the absorber plate and the glass. Here you can see the holes that we've perforated. This is going to be where the hot air will exit. The cool air will come in from ground level in the crawl space, and this hot air will be delivered to the north end of the building, the coldest part of the building. Okay, now this is the inside of the air channel right here. We have that silicone caulk over the fiberglass so that the fiberglass doesn't get into the airstream. And so the next thing we'll be doing is putting in, let me grab a stovepipe. There's one over there, Vincent.
Like one of these guys?
Oh, just a little piece. See, here's what we need right here. Okay. Thanks. This stovepipe will go in right here and go through, and then we'll bend down these tabs onto the duct board and screw in with a few screws to keep this sleeve ready for the fan to adapt to. And we'll do the same thing over on the cold air return. Actually, this is the hot air and that's cold. Because I remember we want to get the fan as close as we can to the electrical outlet. Now,
those screws don't affect at all. Won't affect at all because they're actually
duct board will go in vertically here. They're cutting that now. They're going to put duct board in vertically so that the whole perimeter is insulated. And then C channel to hold the absorber plate. And then finally the glass. Here you can see how that 1/4-inch lip on the C channel is locking in the duct board very nicely. That's the first time I've had that done, where the sheet metal shop was able to put in a 1/4-inch lip. A little more expensive, but it really is wonderful not to worry about that insulation falling into the collector. Is that going in?
Gradually.
If so, then I'm going to put a bead of caulk around there. Let's see. Now, we'll get these in. The C channel, which will hold up the absorber plate, will go in like this.
Up on top.
Okay. Inside the collector airspace right here, we're going to drill a hole and put a thermal probe in there so that the one that says to collector will be determining the temperature inside the collector, and then the other one will go underneath the floor of the house. So we'll have to get longer wire attached here. This glass will take a lot of pressure and pounding in this direction, but if you have something metallic and you hit it on the side, it shatters. So the sides are what we have to be careful with. When we put it down, make sure there aren't any rocks under it, or to protect the sides, and then you've got it made. Let's see. We might need that. Okay, now we could go ahead and put this through that stovepipe, you know. Let's see, I want to have, yeah. Do you need to have something to push it in with?
It's just
Yeah, I don't know.
maybe a piece of wood even just to have a... There's a little piece of wood here. It might work.
Yeah, I know. I'll pull while you push.
Okay. Pushes that down.
What happened?
It'll fold it in.
Oh, I see. Yeah. Well, maybe we need to open that a little more.
I wonder if it's just too snug on the 4-inch.
Let's see. Let me try pushing this in. Yeah, I think it's
That's
going.
doing it. Yeah, that's perfect actually. It just needed that. It's the snug fit of all the material that's going through it. Forming a nice tight seal.
I don't know. Maybe little by little I'm getting it. Huh?
Yeah, I think so.
I don't know. Maybe we ought to open it up a bit.
That has to be flush, hasn't it?
Yeah.
I wonder, have you tried pulling it from the other side? Have you got another one of these guys? And if we're,
I got something that should work.
if I try pulling it from here. Okay, let's work
Okay.
this too.
You ready?
Yep.
Oh, man.
Let's try this. Okay, this one.
No?
Let's go to the here.
Is it going? It went a little bit.
Slowly, yeah. Yeah.
Okay.
Yeah. Wow. It's getting, it's little enough. Okay. Back to here again.
That went down a bit.
It's going down. I think
Over here?
going just work. It's too close to the edge. I can't get my hand quite in.
Oh.
Maybe move it this way a little tad. Perfect.
I bet that's
Try
right.
again. Keep it opposite my. So we're working together.
Okay, let me straighten this out. Or what do you think?
Yeah, if you can.
Okay. Okay, now I'll try to.
Okay.
Okay.
¿Por qué no lo doblas todo para acá y luego le pegas con una tabla o un martillo abajo? Just bend it all this down.
And
The
then,
board and hit it up.
yeah, put
That's
these
true. That might, yeah, that.
put these tabs down and then hit it with a board. Okay, let's try that. Huh?
Stay down when you're done. We can bend it back up.
I think that'll
It's just, yeah.
buena idea, Roberto. Okay, we're talking about putting in a rounded baffle here to help with the airflow. When the air moves into these corners, sometimes they stagnate like whirlpools. And so by putting a baffle like this at an angle, an arch, let's say, it'll make a much more fluid transfer of heat from the absorber plate to the air to be exhausted into the living space. Craig's idea is to hold this rounded baffle in place using tabs that can be screwed into the plywood. And I kind of like that idea because it'll make it real firm. All right, sorry I was in your way. So we're going to maintain a nice straight line with this absorber baffle, and then later we can screw in from outside and pull in the perimeter to make it nice and vertical. Now you got
No problem for a good screw.
How about them Broncos?
No, me encantaría. I want to show you what we were able to do here with Alan's help and Craig Borner's help, you know, to put these tabs on the stovepipe, and we have a real nice smooth pipe here, cut right out of a 5-foot length that'll go through the hose real easily when we mount the collector. And then it's far enough in there under the floor to where it'll be easy to work to put the fan. The fan goes here. And then this one we don't have quite as long because we don't need that much room to put the cool air return, which will be an elbow. It doesn't have to be airtight because it'll be pulling air from the crawl space anyway. This does have to be airtight to be able to push the air all the way to the north end of the building. So what's going to happen is that air will be pulled in through the cold air elbow that goes down to ground level. Cool air will come in. It'll be split real nicely by this baffle, which I love. And it'll curve around and then come into the suction side of the squirrel cage fan. So on top of this C channel here, which we call the absorber support, will be the absorber plate, and that'll be sealed with caulk so that this air space will be absolutely hermetically sealed against the front of the absorber plate and the glass. And we'll be able to see those steps coming right up. Plate,
Okay, okay.
and it'll go on top,
I see.
and it'll come halfway into here.
Okay, just talk about that absorber plate too.
This absorber plate that we're putting in is made out of the same material as the C channel. It's a 16 gauge paint lock, and as we explained earlier, I'm not going to touch it. The paint will hold real nicely on paint lock, whereas with some other metals it would peel off. We've opened up collectors that are 40 years old, and they're still working well in the San Luis Valley of Colorado. Before we put this screw in this absorber plate, I'd like to make a hole. Let's see if we could pull this out just a little bit. Well, it's kind of hard now. I'd like to make a hole right in here from the outside of the collector right through here so that we can put the thermal probe that will measure the temperature inside the collector. So we're going to have to drill a hole and cut a little tube. Did we get that tube cut? Oh, we've got the tube already cut. And so we need to have a drill bit the same size as that tube, and we'll go right into the airspace here. And I'd like to do it before we put the absorber plate in so we can see what we're doing.
Well, also you don't want a whole lot of those shavings in there either.
Yeah. Okay, there's that. Now, just let's see if we can find a drill bit that's this size. This was made out of a curtain rod. I'd like to make a hole. Let's see if we could pull this out just a little bit. Oh, it's kind of hard now. I'd like to make a hole right in here from the outside of the collector right through here so that we can put the thermal probe that will measure the temperature inside the collector. So we're going to have half an inch. Now we're getting the tempered glass down. We'll position it before letting go. So it's just half an inch in all the way around. All right, hey, we got it. There it is. Now, Heart, Mind, Alliance. That's great.